Okay, let's continue. Let us have a simulation of a three-phase power system with different types of load. A load impedance here can be represented by a purely resistive load, or it can be represented by a series combination of resistor and an inductor, which is we can call it an inductive load. In this case, in this example, let's say I have the impedance is 1100 purely resistive, or it can be a series combination of a resistor and an inductor. In this case, the value which I put is 1100 plus J2200, or in polar form, it is set is equal to 2460 with an angle of 63 degrees. Right? And now, or it can be a parallel combination, 1100, resistive load, parallel with J2200, an inductive load, and this impedance is 984 with an angle of 27 degrees in polar form. Now, let us assemble a circuit with a purely resistive load. Right? But before we do that, let me just, since we are going to use an lab bolt online simulation system, let me just introduce to you the different equipments in the lab bolt, right? So let us have this one. Let me just orient you with this. Okay. Okay. This is our lab bolt equipment, right? And this is our power supply. Our power supply, which is, we have two types of source, which is the fixed voltage source. This is fixed in this area here, 1, 2, 3, N. These are fixed voltage source. It is a three-phase. So the values are, it can be 220/380. What does it mean? It means to say that the line to neutral voltage is 220, but the line to line voltage is 380, right? So how can you obtain here, from here, the line to neutral voltage? Let's say I want to line to neutral. I can take power from 1 with respect to N. That is a line to neutral voltage, right? Again, the line to neutral voltage is between 1 to N, or 2 with respect to N, or 3 with respect to N. Now, what about the line to line voltage? What about the line voltage? Line to line voltage, if I'm going to select from 1 to 2, that will be a line to line voltage, or from 2 to 3, or otherwise from 3 to 1. Notice that I am following the sequence, the voltage, let's say E1 to 2, E2 to 3, and E3 to 1. Notice that I am following a sequence 1, 2, 3, right? Because I am using the ABC phase sequence. Okay? Okay, this source is for ABC phase sequence. Suppose I don't want a source that is exactly equal to 380 or 220. Let's say I want, in my load requires 275 volts. So how I'm going to do that? So in this case, I am going to use this variable voltage source. You can see here it is from 0 up to 220/380, right? That means I can vary the voltage from line to neutral from 0 to 220, or I can obtain a voltage of from 0 to 380 volts from line to line, right? So the voltage here is controlled by this knob with this different percentage, 0, 10, 20, up to 100%, right? So now this is what you call the power supply. It also has a DC part. This is variable DC source. This is the fixed DC source, which is 220 volt, right? Notice here, this is a symbol. This symbol is sinusoidal. That means it's AC. This symbol here is a DC, right? This is for DC. This symbol here, a straight line and a dotted line, is DC. This is sinusoidal. This is the AC, okay? Now, so this has to be connected to a data acquisition, but data acquisition must be connected to this 24 volt AC source. So it has to be connected here, right? We are going to do that later on. So it has to be energized, and you need to switch on this one. By the way, this is the main power for the power supply, on and off. 1 means on, 0 means off. So now what about this data acquisition? Data acquisition is just like a voltmeter, a multimeter. So it has a volt, E1, E2, E3, E4. These are used to measure the voltages. And I1, I2, I3, I4, these are these are used to measure the currents, right? So here you can see there are two different ratings of the fuse, 4 ampere and 40 ampere. In the lab, normally we are using only 4 ampere. This is for some special case for having when you're using this data acquisition for large capacity motors. But here, for simulation, we are going to use the 4 ampere, right? And this one here, analog input, these are for the another for you when you're analyzing a motor. There is you can measure the torque and the speed, and these are some parameters that to be connected to the computer. Now, what about this? We have a passive element. Of course, we have a passive element resistive load, capacitive load, and an inductive load. Now, let me focus first here. These are three parallel resistor. Okay, so let me zoom this one. Okay, this first resistor here is 1100, 2200, and 4400. Now, you can notice here, this is 0 and 1. If I want to use this resistor, I'm going to put this toggle switch into 1, right? 1 means on, and 0 means off. So if it is connected to 1, and this is 0, this is 0, these are open. There is no effect on the circuit, right? This is 1100, switch on, and this is off. Now, and also the same here. Now, if I want 2200, I can just switch this one off, switch this one off, and switch this one on, because this is the 2200. If I want parallel combination of 2200 and 1100, I will just connect it, switch on both of them, and this one will be off. And notice also, this is also the same here. In capacitive load, we have a toggle switch, and here also, and for the inductive load. Okay? Right, now let us now do the connection on how do we connect it with our lab bolt system. So this is our lab bolt. Where is our circuit? This here we are going to connect a this one, line to neutral voltage using the lab bolt system. Let us put our power supply, where you will get the power supply. Bring this one down. This is not the power supply. This is the 8821. This is our power supply. And we'll bring 9063 data acquisition. And we'll also bring out our resistive load here. You can put resistive load here. You can put the inductive load here. Right? And you can put also the capacitive load. Okay? Now let's make it zoom here, so that you can see clearly. So now, there you have it. You can now close this one. Okay. Now, let us now to compare this with our connection. As I've said, this has to be energized. This is the power supply. If you connect it here, right? When you switch this one on, you can see the light is all illuminated. So, but it should always be connected, this wire, to power up the data acquisition. Now, for the time being, let's just switch it off. Now, let's say, for example, we have this 1100, okay, 1100 as our resistive load. Let us go to our resistive load. Where is our resistive load? This one. So I want a Y connected load, so that means I had to build a neutral line. So I had to connect this one here as my neutral. Now this is a neutral line, okay? Now this neutral line here is connected to the neutral of the source, right? 4, 5, and 6. So I'm going to use 4, 5, and 6. This is the neutral. So this has to be connected to neutral. I can connect it here. Okay? So now this is the neutral. Now, how do we connect the voltages, voltmeter and ammeter? So now, in the beginning, disregard all the voltage measurement, E1, E2, E3. Disregard the voltage measurement. Let us measure first the current. You can also change the color of the wire from here. So from 4, going to I1 positive, I1 negative into A. So let us name this one as A, B, and C, right? So this is our A, B, and C. So from here, from 4 going to I1 positive and I1 negative to A. Okay, so that's very clear. Now let's go to from 5 going to I2 positive. Where is 5? This is 5 going to I2 positive, right? From I2, so I2 negative is on the other side, I2 negative to B. So I2 negative into B, right? So let's now here, I2 negative into B. So now next is I3, from 6 up to I3 positive. From 6, from, oh, what a minute. Okay, from 6 up to I3 positive. Then from I3 negative into C, right? And of course, our load here, I'm using a load that is 1100 only. Let's say just open this one, open this one, open this one. So all of them, 1100, 1100. They are now Y connected load with this. So now I'm going to use to connect E1 to measure the voltage between 4 and N, right? Between 4 and N, which is also equal to the voltage between A and N. So how I'm going to do that, let's change the wire color. Let's say yellow. Okay, I'm going to measure from E1 going to 4, right? From E1 going to 4, positive, and then negative of E1 into N. So this is our N. So I'm measuring this voltage from the source. Now, next is we will measure what? We will measure E2 from B to N. So from B to N, or from 5 to N, right? From 5 to N. So from here, I am going to use E2 to measure the voltage from 5. And from here, another point, the negative of E2 to N. Okay? Negative of E2 to N. Now, let us measure now E3. E3 is the voltage between node 6 up to N. So E3 is from node 6 and then up to N. To N. Now, assuming our voltage is maximum, right? So, but before we do that, we have to switch this one on. Okay, now switch on. Notice that this has green light. And you can switch this one on here. This is the main power. Okay, after that, what is the voltage for this one? Is 0 to 220 slash 380. So if I will put it in maximum, right? If I'm going to put it in maximum, I will be expecting a voltage that is, what will be the voltage that I'm going to see from the metering? It will be line to neutral voltage. So it will be around 220. So these are the metering. If you click this one here, and you will see the voltages. So E1, E2, E3. We did not use E4, so we will switch off E4. So here we will did not use. So this one here is for the power, right? Power, the power, PQS, real power, reactive power, and apparent power. So this one is reactive power. This is the real power. So if I just click it, so you can see here, it's more than 220. You can adjust also if you want to make it 220. Just a little rotation. You can see the voltage are changing, right? If I change this one here. Okay. Okay, 196. So if I want 220, so I will put it in 220. Okay, 220. It's very near 220. So we can accept now. So, what happened? Now, this is the current. This is the current on the ammeter. The current passing on the ammeter I1. The current passing on the ammeter I2. And the current passing to the ammeter I3. Right? And this is E1, E2, E3. And the multiplication of E1 multiplied by I1 multiplied by the cosine of 0, because purely resistive load, cosine 0 will give you a power of, put this in P, 44.7. Now, if it is purely resistive load, P is equal to S, right? Look at S here. I've changed to S, 44.75. So it's the same. So what will be the total power? Total power is the summation of P1 plus P2 plus P3. Or since we are talking about balance load, it will be P1 times 3. So this is the total power. So we can also set this one here as our M16 meter setting. We can use this as power E4. We can use this PSQ1 plus PSQ2 plus PSQ3. So this one here, apply, okay. So what does it mean? It means it will appear here the summation of power. If you add all of this together, this is now the summation. If you go to Q is 0, there is no resistive load, there is no inductor or capacitor. Now S is 134. So the total power here. Now what else we want to see here? Let us try to check the phasor diagram, right? We discussed about phasor diagram earlier. So let us click this one here. These are the phasor. Okay, what did I click? Let me close again. This one here. If you click this one, you will see the phasor. So E1 is our reference. E1 here, it must be switched on, right? Here also switched on. E2, E3 must be switched on. And let us put the scale. We're talking about 220 volts. So we can use, let's say, around 50 volts per division. 50 volts per division. It's a good scale. Now I1 should be on, I2 should be on, I3 should be on. Let us go for scale 0.1, right? So now let us try to click continuous refresh. So what happened here? The voltage is in phase with the neutral voltage, right? The voltage is, the current is in phase with the neutral voltage. You can see here E1, right? If you look at this portion, E1 is 228 angle 0, E2 220 angle minus 120, E3 222 angle 120, and the current angle 0 angle minus 120. So they are in phase because our load is purely resistive load, right? It is purely resistive load. So now let us also see from here the sinusoids, sinusoidal. So let us see here, channel 1, I want to see the sinusoid waveform of E1, right? Let's make it 100 volts per division. Channel 2, I want to see E2, and let's say also 100 volts per division. Channel 3 also, let's say E3, and also 100 volts per division. And if I click automatic refresh, you can see the sinusoidal waveform, right? This is the waveform of the voltage. Okay, of course, for the current, there will be in phase, it will be a small waveform here. So, but we don't want to see it because the scale are having a large difference between the voltage and the current. So now, this is the phasor, and this is the sinusoidal waveform. Okay, now let us go for measuring the line-to-line voltage and current. So from here, let me just, when you are changing the wire, you need to switch off, right? So in this case, I'm going to delete first the yellow wire, right? Delete all the yellow wire because this one is line to neutral. So let us now measure the line-to-line voltages. What are the line-to-line voltages? Look at E1 here. E1 is between 4 and 5. So E1 is between 4 and 5, right? E1 is between 4 and 5. This is the line-to-line voltage. E2 is in between 5, positive into 5, negative into 6. So it's between 5 and 6. So positive E2 into 5 and negative E2 connected to 6, right? So now we will measure E3 is positive into 6 and negative into 4. So what is here is E3? This is our E3, positive into 6 and negative connected into 4. Now let's again now try to switch on. Okay, and then let's see in the metering. Look at the metering. The metering shows 384, which is line to line. The currents are the same. We did not change the ammeter. And look at the power. It's a very large power now, 201. Now, as I've discussed on the earlier video, you should not take this power. This is a wrong power because it's a multiplication of B line multiplied by I line, right? Because this one here is, the power here is, should be equal to the voltage across this impedance multiplied by the current, right? So you should not take this power, right? 67.05 times. So this, you should not take this power. So you should take the power when you are measuring what? When you are measuring line voltage, line current, and neutral or the phase voltage, right? Line current multiplied by the phase voltage. Okay, so this is how you connect the voltage and the voltages, voltmeter. Now let us do this connection instead of series resistive load only. Let us connect a series and inductive load. But before we do that, I want to show you the phasor of this one. Let's see what happened to the phasor, right? Now, E1 is the reference. E1 is measuring line voltage between 4 and 5, which is this one now. So here is the current. They are 30 degrees out of phase, right? Which I explained to you in previous video. What's the difference between the phase voltage and line voltage? It's 30 degrees, and this line here is in phase with the phase voltage. So that's why they are 30 degrees apart. Okay, so now let's close this one. So let us have a connection. Let me again remove the yellow wire. Okay, I will just click undo. Now this connection is just a current without the voltage. Now if I want a series inductive load and a resistive load, I'm just going to, let's say, delete this one first. Delete this one. Neutral. So I'm going to bring the neutral here, right? This will now be the neutral, and I'm just going to connect this one with this resistive load. They are in series. Okay, they are now in series with this resistive load. What about the neutral? The neutral here has to be connected now here. This is the series connection of 1100 plus 2200. Where is 2200? Which is this one, this second toggle switch, right? So now let us measure again the voltages. Okay, let's measure the voltages. Phase voltages between 4 to N. Right? This is measuring the phase voltages. And now from here, from 5 going to N. Okay, and also from here, from 6 going to N. So these are the phase voltages, right? So now let's switch on and simulate. Let's go here in our it's automatic simulated, so it will show you now that the current has been changed and we have this power, right? So this is now our measurement, and you can see now what happened to the phasor. Of course, the phasor will be what? What do you expect? It will be out of phase, right? It will be out of phase. So click this one here. So again, as auto refresh. So as you can see here, this is our neutral voltage B4N, 5N, 6N, and this is the current I1. This is I1, I2, I3, right? I1 here is the red current. This is the I1 is 0.09 with an angle of 57 degrees, right? So this one here, 57 degrees, and it is lagging the voltage by 57 degrees. So this is what happened when we connected it in series, right? So the line-to-line voltage, of course, you will just need to remove this one, line-to-line. Let us go again. Okay, let's switch off first. So, and then remove the wire. So, okay, now for line-to-line, I will just measure 4 to 5, and then 5 to 6, and then 6 to 4 from these voltages, right? And it will give you line-to-line voltages. And you will see this one here, the reading. Now, what about if I want to do a parallel connection? Parallel connection, what are you going to do? For parallel connection, let me just remove again this one. So, I'm going to make it in parallel. So, I had to, what happened now? Wait. Delete. This one, delete all the stakes. Now to make it in parallel, I have to bring back here the neutral wire, and to make it in parallel with an inductive load, I will just need to put a parallel wire from one at the top, right? One at the bottom, okay? And here also one at the top, and then one at the bottom. Okay, one at the top here. So you're connecting it in parallel, right? This is parallel combination using this load 1100 parallel with J2200. So now let us see again the voltage measurement. Let's see here. I will again line to neutral. Okay, this is also line to neutral. Okay, neutral, and another one which is from 6 to N. So of course here 6 going to N. Okay, now switch on the power, and you can see now the difference. Here is our 2200. Look at what happened. The power is changed. There is a total power, and the phasor diagram. Let's see, it's very important. From here, so we have, this is B4N, and this is the current, right? And this is the current, it's lagging by 24 degrees, minus 144, I2 is lagging. And because all this phase angle is with respect to the zero reference, right? So it is, let's say I1, it's with respect to this phasor, it's minus 24. What is I2? I2 is 1 minus 144. With respect to this phasor here, it is 144 degrees. And the other one, I3, it's with respect to this phasor, it is on this side, you can also write positive 95 degrees. Or you can just 360 minus 95, you can just take this angle, the other way around. Okay? And look at now, this is the, I just show you how to connect resistive load in purely resistive load in the Y connected circuit, series and inductive load in series, resistor and inductive load in series, and a parallel connection, right, for this video. Okay, thank you very much. Have a good day.